In this video, we will discuss several aspects of the Marey PowerPack 110 and our 220-volt version, the PPXE5. We will discuss installation, troubleshooting of potential problems, and settings and adjustments for the unit. First, locate an area to mount the heater. Mount vertically on a flat surface larger than the unit itself, and mount as close to the point of use as possible, but away from any potential splashing water. Next, you will need to connect the water lines. Be sure to remove the rubber plugs that the unit is shipped with before installing the plumbing. When you remove these plugs, water may come out of the unit as they are tested with water at the factory. The connections are 1/2 inch MPT for both the inlet and the outlet and can be found at the bottom of the unit. The cold water inlet is on the right side and should be preceded by a shutoff valve. The hot water outlet is on the left side and runs to your hot water source. Never use PVC on the hot water outlet. Use instead CPVC or other heat-rated materials. Before moving on to the electrical connections, first purge all the air and pressure test the water lines to check for any leaks and correct if necessary. Now let's move on to the electrical connections. The power supply breaker in our video is a 50 amp double pole 220 volt breaker, and the power wires and ground can be connected using wire nuts or other appropriate electrical connections. Use 8-gauge wire for each of these connections, including the ground. 8-2 wire may be used. For the 220 volt unit, also known as the PPXE5, you will need a double pole 50 amp breaker at your panel, as seen here in the video. While the PowerPack 110 only uses 110 volts, so it only requires a single pole 50 amp breaker. When connecting the power wires for the units, the main difference between the 220 volt and the 110 volt unit is that the white wires coming from the back of the 220 volt unit will both be hot, as in L1 and L2. And for a 110 volt unit, the white wires will be a single hot wire and a neutral wire. It does not matter which white wire on the 110 volt unit you decide to make a neutral wire. And on both units, the green wire is still your ground. Now, with the electrical connection secure, let's turn on the breaker to supply power to the unit and set the power setting knob on the front of the unit to 1, 2, 3, or 4. Nothing should happen until you turn on the flow of water. Once you apply water flow to the unit, a red light should illuminate on the front cover. The other knob on the front of the unit controls the rate of water flow through the unit. If you have correctly supplied water and power to the unit and still don't see any signs of the unit powering on, then please remove the front cover of the unit by pushing in on both sides, and inspect the cone in the center of the water inlet valve assembly. You should see the cone raised when sufficient pressure and flow of water are provided to the heater. When the cone is raised, a beveled section depresses on the microswitch, and each switch corresponds to a power setting. Each microswitch activated adds 10 amps of power to the heating element of the unit. Please consider not only the flow but also the water pressure. If it is too low, there may be issues with your setup. If your cone is not raising much or not at all, first check the water inlet screen located just inside the water inlet fitting. Be sure to close the ball valve before disconnecting the inlet. Next, we will go over settings and adjustments to get your power pack to a comfortable temperature. In this frame, you will see that we have several additional devices linked up to the water heater. These devices are to act as visual aids, illustrating how flow rate and incoming water temperature can affect the outgoing water temperature of the unit. The device to the left of the unit has a flow meter that shows what our flow rate is in gallons per minute, a pressure gauge that shows our pressure in PSI, and a temperature gauge that shows our incoming water temperature, which is around 54 degrees Fahrenheit for this video. The device that is mounted below the water heater is the temperature gauge showing the outgoing water temperature in degrees Fahrenheit. Here we also show the knob position for each power setting. The first flow test we are showing for this unit is with a 2 gallon per minute flow rate at 60 psi with an incoming water temperature of around 54 degrees. With these input parameters to the PPXC5, also known as the PowerPack 220, we will receive an outgoing water temperature of around 67, 75, 84, and 93 degrees, respectively, for the corresponding power settings. In the second flow test, we are closing the valve on our hot water return side, which keeps pressure on the unit but will decrease flow rate. In this test, we are supplying 1.5 gallons per minute to the unit with around 60 psi and an incoming water temperature of around 54 degrees. With these inputs and the unit set on power setting 4, our outgoing hot water temperature will raise to be about 108 degrees. So as we decrease our flow rate, we achieve a longer contact time on the heating element, thus giving us an increase in our outgoing water temperature. In our third flow test, we are reducing our flow rate even further, down to 1 gallon per minute, with our pressure increasing slightly to around 63 psi, and our incoming water temperature is now around 56 degrees. By reducing our flow rate to 1 gallon per minute, we now have an outgoing hot water temperature of around 137 degrees on power setting 4. When you want to decrease your flow rate to the unit to increase your outgoing water temperature, please be sure to reduce the flow rate by closing off the shutoff valve on the outgoing hot water side of the unit. In this clip, you can see that if you close the input water valve to decrease your flow rate, you will also decrease the pressure on the unit, which may drop the pressure enough to cause the micro switches to disengage and thus shutting down the unit.